Okay, let me share my screen. Okay. Okay, welcome to the ChainSync, and yeah, we'll start by getting an update from everyone. Yeah. Misha, do you want to give us an update?
Yes, I have a small refactor to prevent the bugs like the bug from last week.
You mean the epoch first block of
the
epoch?
chain store update.
Ah, refactor chain store update.
Also opened an issue for another bug in CrossShard TX. Seems like a potential bug with block syncing. And I started looking into performance.
Okay. Oh, KPR, you're here. Do you want to give us an update as well?
Yeah, sure. I basically updated send approval function, which takes so it basically now understands if Apex Sync is in progress and not sent approvals in this case. And now tests are failing in basically two ways. One of them is related to check send announce account. So sometimes it says that when we call their function get next epoch ID from previous block, it says it has no data and return with unwrap error. And another problem is and it looks like it's related to sometimes not getting stuck getting this message. So I think it might be related. So it looks like that it's continuously trying to send announce and to do it in a loop.
Announce. Wait, which test is this again?
I'm testing it on let's say it called epoch sync then epoch sync.py.
Okay. But what about what is the send announce thing you're talking about?
Check send announce account is the function in
announce
vector.
account. Okay, sorry, I just misheard that. I thought you talking about announce.
Oh, sorry for that.
Yeah, no, yeah, I think just misunderstood.
Send announce account.
Announce account. Okay, so I see. Yeah. So that requires. Yeah, I mean, yeah, if that function is broken, yeah, your test would likely fail because the validators cannot know how to communicate to each other.
And what to do?
Well, it depends on why it fails. But that needs to be fixed if that function cannot fail.
I see. Okay, and another issue I found that so sometimes when the test almost finished, I found that there is some data which is not deleted properly. So I haven't digged into it, but it looks like we download something or not GC properly. So I need to investigate more.
Okay. So you said that the check send announce account fails because you have trouble getting the epoch ID or something like this, right?
Yeah, so it looks like that function that gets next epoch ID from prev block fails because there is no data in the database.
Get epoch ID from prev block. Is it because prev block doesn't exist?
Yeah, I can't say for sure, but it looks
Okay.
like what's happening.
Okay, let me quickly take a look at this. Send announce accounts. So I'm just trying to understand why it needs to. Oh, I see. Well, actually, well, I suppose it's not. I mean, like, okay, you need to do more investigation on where it is called. But for example, you can actually pass it the block or something, or pass it the epoch ID. Like you, and avoid getting calling the get epoch ID from prev block there or something like this. But, okay, yeah, need more investigation now. What's going on there?
Thank you.
Okay. Yeah, I think that's everyone. Okay, so yeah, maybe we can continue the discussion we had last week. Yeah, Alex, do you want to share your screen? Or
yes, 1 second. Okay, can you guys see it?
yep.
Okay, let me send it to chat. If anyone wants to join. Okay, where did we stop last time?
I think you were describing the Starlight idea.
Right. Okay, I don't remember where exactly I stopped. So let me quickly cover again the motivation. So motivation is to have very cheap shards which can execute transactions. Well, ideally at the prices within less than order of magnitude from centralized clouds, which are on itself more expensive than bare metal. So the idea would be to say, to start with what we have today with Nightshade. So in Nightshade, what happens today is at the boundary of the epoch, we have some number of proposals to be validators. And we choose, well, this is not built, so it is hard to tell what is supposed to be. I don't think the Nightshade paper is sufficiently specific, but I think naively, if we were to enable Nightshade right now, we would have some constant number of validators, and they're assigned to shards. So idea in Starlight would be similar. We would have some number of shards, which could be static, could be dynamic. And then I think that much we covered last time, right? I want to sample 6 N validators. to validate the shards, of which 3n are explicitly assigned to the shards. 3n are sampling shards locally to validate. They are hidden validators. And the big question here is what to do if one of the shards. So what sort of failures can happen and how to handle them, right? So in Nightshade, the idea was along the lines of first actually having more than 3 validators per shard, right? So for example, if we launch simple Nightshade, in simple Nightshade, they plan to have around 100 validate, well, in simple Nightshade, everybody validates every shard. But I think in general, when we were thinking about numbers for Nightshade, the idea was that we would have like a 10 or more validators per shard. And so it is very unlikely that all of them go offline. Obviously, if we only have 3, so those 3 are explicitly assigned and produce chunks. 3 are hidden. Right. Oops, what just happened? Oh no. How do I redo it? Well, unfortunately, it got erased. Anyway, so with 3, there's a decent chance that all 3 go offline and the shard stalls. So for that, I have no solution besides increasing the number. It could be tempting to do something along the lines of saying, well, we still have some of them hidden and have state. So it would be great to bring them in. But that's hard to do without revealing all of them because we don't know how many of them there are. We cannot, at least I don't know how to do it deterministically. We cannot bring just one of them and not bring all others online. But let's for now, so let's just acknowledge this problem exists and get back to it shortly. After the more pressing issue is what happens if the shard is corrupted. So in Nightshade, the plan is that if the shard is corrupted and an invalid state transition happens, then we report it to the main chain and the entire chain gets reverted, right? So this is the main chain. And so let's say that somewhere here in one of the chunks, an invalid state transition happened and the chain has been building further. And eventually someone sends a challenge for this chunk. And it's recorded somewhere around here in terms of time. So what happens is that everybody who sees the challenge considers this entire chain invalid and starts building from here. And here in the very first block, the challenge is recorded. Right, so there are 2 ways to get the challenge. When this actually happens, you will get the challenge from the gossip network. But later, when you sync, you will get the challenge from the first block, which was built on the new chain that forked out. So that was the initial plan. I'm not fully convinced this is the best plan because that means that the cost of reverting chain is actually pretty low. It's sufficient to corrupt 1 shard. And so even if the adversary cannot gain much by actually corrupting state because it will be quickly reverted, they might gain quite a bit by reverting the chain, right? So they can do, effectively it makes doing double spend significantly easier. Of course, you can only do double spend against someone who does not validate all the shards and who does not wait for the challenge grace period, but it is still pretty, it's still pretty cheap. Sounds to be pretty cheap to revert the entire chain. So the alternative approach is to do what Cosmos does and effectively say, well, if there's an invalid state transition, then we do not consider the entire chain invalid. All we do is, so like if we draw this chunk here, so this is this chunk, and it has state root 1. And then there's another chunk here, another chunk here. And so then the challenge happens. And so the idea is So there was some other state root 2 here, state root 3 here. And so the idea would be to say that if the challenge occurs, and we prove that this state transition was invalid, then we send the challenge. And as challenge is recorded, so the challenge ends up in the block, somewhere recorded here. And in the block in which the challenge was recorded, we just undo the state root to state root before 1. So let's say it was state root 0 before. Right, so effectively we're saying that we do not guarantee. So the problem with this is that the state root 3, so shards are not completely separate, right? There are some cross-shard transactions happening. And so it could be that there were, well, not could be, but there were some other chunks in other shards, right? So this is another shard, let's say. And there were some cross-shard transactions happening, right? And so they were affecting each other in some way. And so obviously by reverting the state root, we're making the state of this shard to be inconsistent relative to the state of the shard with which it was communicating, right? So it's like if we imagine that they were exchanging some assets, it could be that some assets were born out of thin air or lost. And so to this extent, what we can do is we can say, well, we do have several, well, initially one. If we don't have Moonglow, it will always be one. We do have one shard which everybody tracks. Let's say it's called shard 0. So, oops. So let's say that shard 0 is tracked by everyone. And we're saying that, well, if you do want to have, like for any asset transfers, do them through shard 0. So shard 0 is tracking all these super critical assets. And shard 0 is not corruptible unless you corrupt the entire chain, right? And so in other shards, you should always be prepared to the fact that there is some theoretical possibility that they get corrupted and the state gets reverted. And so the APIs and the applications need to be built in such a way that, well, stuff doesn't break very badly if this happens. Does it make sense?
So how much asset transfer would be, I imagine like even between applications, there might be some cases where you need to attach near to your cross contract call or something like this.
Yes, the question is how much near you need to attach, right? So obviously, nobody will be reverting state for like very little amount of near, right? So if someone is reverting, that must be a large amount. So the big problem here,
it's not actually. It's not that.
Go ahead.
It's not necessarily the amount, right? It will actually just affect the total supply because you're actually just minting money out of thin air.
Yes, this is a good point. So effectively, for non-near, right, for ERC20s, their balances are recorded in a smart contract, right? So there's a smart contract somewhere on the main shard where the balances are recorded, right? So that is, at least today, we do not have a standard for ERC20, sorry, for NEP, for fungible tokens that stores balances on the shards of the accounts, right? So those are unaffected. So near is a problem, yes. I don't have a good solution besides effectively saying that like in essence, if some near left the shard in the meantime, right? So in state 0 was like X near. Right, and there's more than X. Then as we reverted, sorry, less than X. I guess this is the interesting case, right? So as we reverted, we do print near from the thin air. So we do need to do something about that. Well, one possibility is to say, well, we're not reverting the balances. Another possibility is to proportionally punish every account in this shard. So like if some near is missing, as we undo the state, we don't undo it per se. We we take away near from everybody who is in the shard.
Well, like how? But that's not even very
Easily
easy to
doable, yes.
implement, right?
Right. So what happens in Cosmos? I also don't know if this is implemented or not. I just know that this is the plan that was mentioned in the whiteboard series. What happens in Cosmos, where assets can move between chains, right? Is that the hub, right? So there's a hub, and there are small spokes, right? And so imagine that there was some money transferred from this zone to this zone, and also let's say that this is a pretty large amount, right? So there's like a huge amount of money went through the IBC from zone 0 to zone 1. Just later to learn that zone 0 was corrupted, and this huge amount of money actually was not authorized to leave it, right? So what happens? So like imagine there are two people here, Alice and Bob, having some money, and Alice had all the money, but then Bob corrupted it and changed the state root in such a way that Bob has all the money and he transferred it out. Well, from perspective of the hub doesn't care. All hub knows is that, all hub knows is that this zone has all the money, and this zone does not have all the money. And so it is up to the zone. The hub doesn't care, right? So it is up to the zone how to handle the fact that Alice, according to the state, shall they revert the state in this case, has all the money, but the zone actually does not have the money, right? The hub will not allow any more money to be transferred from the zone, or like this huge amount of money that was transferred out in the ledger of the hub is now in this zone, not in this zone, right? So all hub knows is that how much total money exists in every zone, and zones have to handle such failures somehow. Well, we cannot assume exactly, we cannot do exactly the same thing. In our case, we are aware of what happens in the shards, right? So if the shard is corrupted, but money moved out, well, money are gone. We need to handle it in some way. Well, one option is obviously still to unroll the entire chain.
So actually, how is the ERC20 or fungible token case different? I mean, like you still can call it from other shard, and that transaction is kind of reverted, right? But then you need to manually revert it on the shard 0 as well.
Well, you cannot revert it on the shard 0 because that's the entire point. That if in case of
but so what do you do with?
Yes, well, the point is that if we do not revert the entire chain, we cannot revert the receipts because the destination shard performed some action. Destination shard was not corrupted. Destination shard was told you received some money, perform some action, it performs some action. So we cannot, unless we revert the entire chain, the money.
Yeah, exactly. That's why I'm asking, like, why do you think the ERC20 or the fungible token case is like different from the native case?
Because from perspective of the destination shard, nothing bad happened. In case of near, the problem is that
but isn't it true that you can?
But you cannot print money out of thin air. Yes, you make it inconsistent, but no money was printed out of thin air.
I see. Okay.
Right. The state of shard, the state of the corrupted shard isn't consistent, which is, well, it was corrupted.
Okay.
Right. But no money was printed out of thin air. Right. The balances checked out because balances were tracked on shard 0.
Yes, but the balance can be in an inconsistent state, right? It's sure no money is minted, but that doesn't necessarily mean it's just there's no problem.
Well, without obviously, if we do not unroll the entire chain, the state will be inconsistent by definition. There is no way to make state consistent.
Yeah, sure. Okay.
If for multiple blocks, completely invalid state was creating receipts, like a completely corrupted shard was creating receipts. So state will be inconsistent. The question is, can we make this inconsistency to be contained within the shard which was corrupted? Right, and then from there on, if you deploy to a shard, you operate under an understanding that the shard can be corrupted.
Wrong approach to try to contain. I mean, we try to make shards transparent, and so the behavior of the system shouldn't depend on what is in what shard. We want to be able to reshard it like at any time, and now you try to somehow say that if you happen to be in the wrong shard, you can get like punished for that, and it's not something like Cosmos where shards are like explicit. We want implicit shards. People should just be able to use accounts and get benefits of sharding without having to think of what is in what shard and like how secure is each individual shard and so on.
Yes, that is a good point. If we want, so with the assumptions you mentioned, if we want people to be living all over the shards for all possible use cases and assume shards are completely independent and have dynamic resharding, then this approach is pretty disastrous. On the other hand, if we do not have dynamic resharding, so for example, if we say there is no dynamic resharding, shard boundaries are fixed, and like every shard has its own gas auction, then as you deploy somewhere or as you use the application, you're fully aware of the security guarantees of the shards and under which circumstances the shard can be corrupted
But this
and the state can become
makes
inconsistent.
the developer experience worse because now developers don't, instead of having a single secure blockchain, they have many insecure blockchains.
And one secure, right? So if they do want to have to build some financial use case,
And one
they
secure
do
but
yes.
expensive because it's not sharded. Basically, we already have a single secure blockchain. It's called Ethereum.
Yes, that's the case. However, again, first of all, we can shard it to some extent, right? We cannot shard it infinitely. We can shard it to an extent to which the expensive nodes can still track all the shards, while majority of the network can still run on the cheap hardware and only validate the subsets of it. So we can still shard quite a bit the synchronous environment of shard 0.
I think this way we are going to build some sort of clone of Cosmos or Polkadot. I think we wanted to differentiate ourselves by having a single homogeneous blockchain without this, with a single security, like not the central blockchain and additional less secure blockchains.
Right. So
Okay. Yeah, I think we're out of time. Let's maybe discuss it